Hello ECM Podcast 的听众朋友们，大家好。那这一期呢，又是非常特殊的一期，这是一场关于去中心化定序器的圆桌讨论。那么这其实是我们策划的去中心化 Rollup 系列的第2集。上一集我们和 Patrick 聊了真正的 Rollup 应该具有什么样的特性，以及应该从哪些方面去判定一个 Rollup 的安全性。这期节目呢，我们还是使用英文进行讨论，底下的 notes 栏里呢会有本次 panel 的中文转译文本。好了，那么事不宜迟，我们就开始这个 panel 吧。Okay, the Chinese introduction is done. Why don't we get started with introducing yourself and your team? Yaoqi, you wanna go first?
Yeah, thanks for Francis intro. Yaoqi here. So I'm the founder of AltLayer. So at AltLayer, we're building the Rollup as a service platform. So we would like to help all the developers to basically click a bunch of buttons and configure the parameters. So we're our launchpad or control panel, so they can quickly launch application-specific Rollup within 2 minutes. So that's something we're also trying at the moment. Meanwhile, to provide a versatile execution environment and features for the developers, we also provide its multi-sequencer, multi-VM, and fraud-proof and various different proof system for the developers to choose. Yeah.
Okay, Abdel,
yes.
Okay.
Yes, so I'm Abdel. I'm working at Starkware. I'm the lead of the exploration team. So basically, the goal of this team is to launch open source projects that are kind of a research project, but with a strong engineering focus. And the goal is to work closely with the community, people from the ecosystem and also from other ecosystem working together on open source projects. And one of the projects is Madara, which is actually a Starknet sequencer that is both a candidate for the public Starknet, but also a sequencer for Starknet app chains, layer 3s. So this is also related to what the previous guest said before. So we are also considering this Rollup as a service world where people can launch their Starknet app chain and have some kind of modularity, choose between different data availability solutions and whatnot. Yeah, and before that, I was an Ethereum core developer for 4 years, mainly working on EIP 1559.
Okay, Toghrul.
Hello, my name is Toghrul. I work as a researcher at Scroll. So my main duty as Scroll is protocol design, bridge design, decentralization, incentive, stuff like that. So yeah, most of my time is spent when I'm not shit posting on Twitter, just doing research on how to decentralize the protocols, so sequencers, provers, stuff like that. Same as Starkware, one of the things that we're also looking into is Rollup SDKs. So basically that you can launch a scroll-based Rollup with different, that is modular, so you can use different data availability options, etc. And we're considering how an option where the Rollup that is launched on top of Scroll SDK can use Scroll sequencer to basically help them with decentralization instead of them every single Rollup dealing with the decentralization itself. Obviously, nothing is finalized yet, so everything, as everything with Rollups, I guess, everything is still under consideration. But yeah, that's the direction we're looking into as well.
Yes, okay. Okay, it's great to have you guys here. So without further ado, let's go into the first topic. So what is a sequencer in Rollup? Is it very important to a Rollup? Anyone can help give it a definition and what's their functions?
Okay. I can jump and start. Okay, so basically a sequencer is a very important component in layer 2 architecture because this is a component that will receive transactions from user and then pack them and bundle them into blocks and execute the transactions, etc. So it is a very crucial component of the architecture. because this is the component that will have the responsibility of creating the blocks, because ultimately a layer 2 is also a blockchain with blocks and transaction blocks, and the sequencer is the entity that will create those blocks, and then the prover will prove those blocks. But the sequencer is the first entity that is creating the blocks. Yeah.
So as Abdel mentioned, right? Actually, the sequencer is basically a combination of lot of functionalities in blockchain. So compared to the typical public blockchain, right? Actually, right now we probably give sequencer too much responsibility. So it basically first need to aggregate all the transactions from the users and then order these transactions, like basically either based on the gas price or it's a first come, first serve. After that, the sequencer need to execute these transactions. Like right now, most of the L2s are in EVM, right? Of course, Starware has a different virtual machine, but basically the sequencer need to use the dedicated virtual machine to execute the transaction, generate a state. And after that, it sort of turns the system into a pre-confirmation stage. So right now, if you look at all these 1 second or 2 second, even like sub-second confirmation time, right? So basically, it's like a pre-confirmation, finalized by the sequencer side. And after that, for most of the sequencer, they also need to upload or post that sort of the checkpoint or state hash to L1s. These sort of like confirmation on the L1, or we call it data availability, right? So the sequencer need to post the state root hash of all the state and the process the transaction to L1 along with comprise the transaction body. So as you can see, right, the sequencer actually basically has so many roles in the Rollup system. And but in the end, you can really treat it as the L1 offload all the computation or execution functionality to the L2 sequencer, and we'll finish all the tasks. And in the end, it will upload sort of a state root hash to the L1 to tell the L1 that everything is finished. And if you have something not going right, and then you can in optimistic rollup, you can do a challenge where the fraud proof, and in the sort of ZK rollup like Scroll and Starware, right? They post the validity proof, so immediately one can just check whether the interstate transition is correct or wrong. Yeah, but in general, it's I think it's the most crucial component in rollup system. Yeah.
Okay, so I guess you mentioned about sequences are burdened with too many functionalities, and so I guess we will talk about this more about the separation of these their roles. Okay, so okay, that's clear. So we are now aware that sequencer plays a very important role in the rollup, and just as I mentioned at the beginning, by now, almost all L2 projects have centralized sequencers, and we are now in the process of decentralizing the sequencers. So this brings us to the next topic. Why is decentralizing L2 sequencers important? So if we are using centralized sequencers, what are the hidden dangers brought to the users and the rollup systems? So basically, what are those disadvantages? Anyone give us an overview about this, about their disadvantages?
I can go here. Firstly, it's important to understand that in rollups, and bear in mind, I'm talking about rollups that don't actually exist right now, because some of us still have some training wheels implemented, actually all of us except few V1. So none of us can actually be classified as a rollup in the current stage. But let's say that once everyone does everything to be classified as a rollup, so you remove the multi-sig, etc., then the problem of sequencer decentralization becomes a UX issue, not a security issue. So when people talk about, like, let's say, decentralizing an L1, the problem is completely different, because the L1 has to guarantee ordering and also provide some guarantees to the light client. So let's say if a light client wants to verify that the state is correct, they have to trust the validators of that L1. Whereas for rollups, that's not really the case, because in the case of a rollup, the sequencer just provide temporary ordering that is then confirmed by the L1, which means that, and because we also, rollups also guarantee censorship resistance, we don't need decentralization for that. So the reason why you need a sequencer is threefold. So one, let's say if the finality on the L1 is slow, either because you submit the validity too slow or whatever, or in case of an optimistic rollup, the fraud-proof times are like 7 days, you have to rely on something to confirm it fast. So, and while you can trust that, for example, Starkware are not going to rug you, and actually when they say, or Scroll, when we say that a block is confirmed, we're not actually going to reorg it later. It's a trust assumption, and decentralization can add some economic guarantees, etc. On top of that, rollups don't have real-time finality guarantees. So essentially, you can go through the L1, you can force include the transaction, but it'll take hours for that transaction to be included. And for a lot of use cases, an hour of waiting time is equivalent to infinite waiting time. So let's say if there's an Oracle update and at volatile times, then basically if you update the Oracle 1 hour too late, then the whole system might fail. The whole app, sorry, not the system as in the rollup. And essentially decentralization allows us to provide some stronger real-time censorship guarantees, because instead of corrupting one entity or like a handful of entities, that now you have to corrupt the whole network of sequencers who are working together to produce blocks. So it's more of, for us, the decentralization is more of a solution to improve user experience and fix some edge cases like Oracle updates, etc., rather than provide basic safety guarantees, which is the case for L1s.
Yes, I think this is very important what you said about the clarification about why we want to decentralize, because as you said, this is not exactly the same problem as the L1. And I think it's important in the discussion, because when we see some AltLayer ones that are criticizing decentralization of sequencer, they are not honest about the trade-offs of having a centralized sequencer. So it was very important for you that in school that you clarified that. And on top of that, I would also add something else that is related to the user experience, which is about liveness. Because when you have one sequencer, you have more risks of the sequencer going down for whatever reason. So decentralizing the sequencers also add more resilience and liveness on the network. But yes, even in a centralized context, in terms of security, we have good security guarantees. And the difference is mainly the timeline, because indeed, when you have the possibility of forcing transaction to the L1, what the difference is only about the timeline. And having decentralized sequencer enable you to have fast censorship resistance guarantees, as Toghrul mentioned. So yeah, I will just add that also for liveness, it's also important to have a decentralized network or sequencer.
Just want to have some points to add. So as we all know, right? So the liveness probably that's the most important thing we need to consider at the current stage, because if we look at recent cases, right, for the airdrop happening on the most popular L2s, right, or Optimism, Arbitrum, like both of them, they have some downtime during the crazy sort of participants during the airdrop, right? So I think in general, right now, it's really like how we can handle like, for example, $1,000 of transaction per second, or even $1,000 of requests per second. If we just have one sequencer, I mean, So even in theory, it's not possible really to handle so many requests or HTTP or WebSocket connection at the same time if you just have one node. So regarding liveness, right? Definitely we need multiple sequencers. Single point failure is really like sort of the hurdle for not just for Web3, even in Web2, it's a big issue. And beyond that, right, it's also about like censorship. If we just have one sequencer, right, even we see that it can be run by the team, but you still need to show that you don't really censor transactions. For example, sometimes like there's some malicious parties, all right, there's some other party you don't like them. So is it possible you have the ability to blacklist them? And if it's a decentralized like sequencer system, right? At least if they cannot send transaction via one sequencer, they can also try out the other ones, right? So that's why like recently we got a lot of criticism like around like the single sequencer is really like the L1 protocols. They may complain about the censorship issue. Yeah, beyond that, there are also some other issue, right? Like MEV from running. If it's already centralized, right? So sometimes, right, especially for DeFi protocols, they may want to have the shortest link to the sequencer. Then they can make the advantage of advantage of like they can have the fastest route to send transaction, right? Then probably they can easily check the mempool and to do, may not be front running, but they have a better opportunity to backrun a lot of transactions and to do the arbitrage. Yeah, so a lot of these issues, I would say, even we say Rollup L2 are quite different from the L1 due to various reasons, right? But in the end, since it's, in the end, we need to make it as decentralized as possible, right? So we have to face some of the similar problems we were having at the public blockchain or L1 side. Yeah.
Yeah, I also, like, we saw that it's important to decentralize the sequencers, but I also want to say, and we all know that it's not an easy problem. It's a very hard problem, and also because rollups have very special architecture, and there are multiple entities. Like there is a sequencer, which we are talking about, but there is a prover, and you need to decentralize both actually. And there are some trade-offs, and so there are some difficulties around how you price transactions because there are different factors that are required to run the network. So how do you price transaction? Because, for example, the sequencers and the provers don't have the same hardware requirements. Like, for example, the prover needs to be a super powerful machine and so on. And so pricing transaction in a decentralized world is also a very hard problem. And this is why it takes time. So we will all face the trade-off of if we want to decentralize fast, we will need to go probably with probably some training wheels again and start to decentralize progressively, because if we want the perfect architecture directly, it will take years. So I think we will all go with a pragmatic approach and try to decentralize progressively. At least this is what we plan currently, like probably start with a simple BFT consensus mechanism first, and then add another consensus mechanism after a short period, and stuff like that. So just want to say that it's not an easy problem. It's hard, and we will face some trade-offs because there is obviously a trade-off between the velocity of development and how the architecture will be suitable for decentralized environment.
Okay, so basically we could classify those dangers into two primary points. One is censorship and another is a real-time liveness. Okay, so thank you all for those awesome explanations. So now let's move to the last but not least topic. This topic can be huge, and I think all of you want to present many opinions about how to decentralize a rollup sequencer, because that's what your team are doing. So what are the potential approaches of decentralizing sequencers?
So how to decentralize? Yeah, this is a very good question. So I would say that there are different functions that we want to decentralize, and all of those functions have different trade-offs. Like, for example, when you want to decentralize, you want to introduce some kind of consensus mechanism, and in the consensus mechanism, there are multiple parts. For example, the first one is the leader election, like how you choose who will create the block, who will be the sequencer to create a block at a given slot or given time. What we plan to do, we want to leverage as much as possible the layer one. So that means that for our leader election algorithm, we want to have the staking happening at the layer one. Like, for example, we have the token, and the staking will happen on the layer one on the smart contract on Ethereum. And then we want to use that to determine the leader election mechanism. That means like we want to do kind of like Ethereum with some epochs and slots, and the leader election will be determined by the staking on the Ethereum smart contract. So that means we need to have some interaction that where the L2 sequencer will query Ethereum smart contract to know who will be the next leader and whatnot. So obviously you need some kind of randomness and whatnot. So it's not an easy problem. But this is the first part. The first part is the leader election mechanism. Then you need the mechanism for the consensus itself, and then you have multiple options. Either you can go with longest chain or BFT or a mix of both, like Ethereum, which has LMD Ghost and Casper FFG for the finality. So likely we will go first with a pragmatic approach where we start with BFT first. And why is that? Is on the layer two, when we want to decentralize, we don't aim for the same number of sequencers as the layer one. For example, on Ethereum, it's very good to aim for millions of validators, literally. This is why we cannot just use a BFT mechanism, because it will be very bad in terms of efficiency, and it will cause very big problems if it was the case. Like, for example, this night, there was a problem on the Bicot chain. If it was the BFT mechanism, the chain would just have halted completely. But it was not the case. The chain continued to create blocks, and only the finality was affected. But on the layer two, if you aim for, let's say, a few hundreds to 1,000 sequencers, it's probably fine to start with the BFT mechanism. Okay, so we have the leader election, then the consensus, and then there are two other parts, but I will stop there to let other guests speak. But the two other parts are the state updates and also the proof production. The production of the validity proofs of execution and how you submit and settle all of that on the underlying layer, which is Ethereum, or it can be also layer 2 if you are on the layer 3. Yeah.
Toghrul, can you add more about this?
Yeah, of course. Let me start off by saying that in L2's decentralization is a multifaceted problem, as Abdel described. So one you have, especially in ZK rollups, because you have provers and sequencers, and you have to coordinate between them, and you have to decentralize both. And yeah, so the problem is quite different to the L1. And another difference is that in here, all your designs are geared towards convincing the underlying bridge of the correctness of the consensus or whatever you use to decentralize, instead of convincing a bunch of other an arbitrary number of other nodes. You obviously should do that as well, but your primary focus should be the bridge itself. And so currently we have two different directions we're looking into. One, I think, as everybody else, we're looking into BFT protocols, so Tendermint, hot stuff, etc., because that's just the easiest way to do it. Just slap the consensus on the sequencer and call it a day. It's not very efficient, and there are a few problems that need to be solved. So, for example, and we have rough solutions to them, but it's still not optimal. So, for example, one of the issues is how do you balance the incentives between the sequencers and the provers? Because the sequencers control the MEV and the provers have no access to MEV, and therefore the incentives dictate that people should run sequencers rather than provers. But in reality, we need more provers than sequencers. And so how do you balance the incentives between the two? It's one of the problems. And a second solution that we're working on is second path. And bear in mind, things might change. A new proposal comes out every day. So for example, recently there's been a lot of discussion about based rollups and how you can completely outsource sequencing to the L1. But yeah, and the second path is basically you can completely drop the sequencers and use some external builders. So for example, Ethereum builders or Flashbot, Suave, etc., to propose ordered blocks and then run the consensus within the provers. The problem there is that it simplifies. The positive there is that you don't have to deal with the incentives because basically you can enshrine PBS and then deal with PBS internally, and it creates a much simpler protocol. But the downside here is that because we need a lot of provers, because we can parallelize proving, it's quite difficult to run a classic BFT protocol with them. So the question is, how do you optimize the existing BFT protocols like hot stuff, etc., to run with hundreds, maybe thousands of provers? And that's not an easy question to answer.
So you all mentioned about random selections with some POS set or mechanism. So I just have one more question about this, is that do you think we need L2 local consensus to do this?
So I can roughly answer this question, as we recently just launched something similar. So so whether to use consensus, actually it's not depending on depending on if we want or not. It's once you have a lot of sequencers or even just nodes, right? You have to let them reach an agreement. If it really depends on the assumption you have. If the assumption is Byzantine assumption, right, we can use the BFT hot stuff or whatever the existing Byzantine consensus protocol, right? If it's a non-Byzantine setup, like for example, if we just assume the node can only be up and down and it won't behave maliciously, right? Then we can use Raft or some other faster consensus protocols. So, but in the end, if we really have that sort of a set of either sequencers or provers, right? If we want to organize them together to generate sort of a grade block for a period of time, then you must have a consensus protocol around them. You can use different ones, but in the end, we just give a name to that kind of protocol. Let's call it a consensus protocol. So yeah, as Toghrul and Abdel just mentioned, right? I believe there are a lot of sort of proposals and research topics around how we can achieve the decentralized sequencing or sort of the proving system, right? So because we just launched our testnet for this multi-sequencer rollup system, even right now we only support this optimistic rollup with a fraud proof. But based on our design implementation experience, there's something I can share a little bit about the difficulty. As Toghrul just mentioned, right, the difficulty is not about the consensus protocol itself. It's really about something beyond that. For example, the proving part. Because if it's a single sequencer, right, you don't really have the sort of a lot of nodes, right? The run a consensus protocol. What we have for most of sequencer is we can treat it as a EVM, a virtual machine. So you just take transactions and execute and do the state transition. So what we need for the prover, if it's in a ZK rollup, right? So need prover to do is to generate proof for the previous set of transaction or instructions, right? So in that case, it's really to prove the correctness of the instruction causing the state transition. But if we really run a consensus protocol at L2 or Rollup for the sequencer approvers, right, then we need to introduce the extra consensus logic there. So you have a lot of key management and then the exchange, like sort of the messages, and basically on top of it, you need to have a proof system for the consensus protocol at the same time. So it will introduce a lot of work for the proof system to generate. And then like sort of once you generate proof, right, you can easily verify on the L1 like Ethereum. So that's why somehow when we did our first like sort of testnet with the multi-sequencer, right, the optimistic rollup sort of has some advantage there. So you roughly, you can simplify a lot of things without considering the validity proof part. But you can like us, we basically compare everything into WASM. So in the end, it's a WASM instruction level. So it's relatively easy to be verified using the Solidity code. Like verify these WASM instructions if we just have the re-implementation of all the WASM instruction interpretation on the Ethereum. But in general, as you can see, right, when I describe it, it's not a single point about the problem. If we have a solution for the problem, accordingly, there will be some other follow-up, like subsequent problems you need to tackle at the same time. Of course, there will be some MEV issues, like how we distribute the MEV fairly. You can distribute it like to all sequencers and approvers based on like sort of whether they produce a block or whether they verify the block. Yeah, but in the end, it's a really a combination of a lot of issues, not just a technical issue and also the economic issue. Yeah, if further we bring like sort of the staking and slashing here, we also need to decide, for example, which sequencer, which prover is behaving maliciously. We need to slash them. And and on the L2, the thing we need to remember, we need L2 because we want to significantly reduce the gas cost, right? So we cannot include so many nodes, and in the end, the L2 probably costs more than the L1. Like when we do the transaction execution or proving. So yeah, so it's really need to figure out like a balanced way to address this kind of question. Yeah.
Yeah, so I want to add something. So first of all, yeah, sure, optimistic rollups have advantages if you don't care about security. No, I'm kidding. Just saying that, we all know that none of them have actual permissionless fault proofs, which is a shame, and I will continue to say it every time I have the opportunity, because we need to be honest in the comparison. So they are not L2 at all. They don't have fraud proof, and I will stop calling them L2 until they have fraud proofs. So this was the first thing. Then I want to add something about the asymmetry between the sequencing and the proving, because it's very important. And as you said, we want to optimize the sequencing, because currently I guess this is a bottleneck for all solutions. But it's fine in the centralized context, because we know that the sequencer will only generate valid transition, and we will be able to prove them. But in a decentralized context, it will be much harder, because maybe your sequencer will be able to generate something that won't be provable, and then you will need to deal with that later. So this is a pretty hard problem. And to optimize on the sequencer, because we don't have to generate the proofs on the sequencer, we can try to go to native speed. Like this is what we want to do, like translate Cairo to a low-level machine language like LLVM and run super fast on the sequencer. And then you can prove asynchronously. And the cool thing about the proving side is that you can do it in parallel. This is massively parallelizable with proof recursions. And this is why we will be able to catch up with the speed of the sequencer, but it will be hard when we decentralize, because we will need to make sure that the sequencer will generate only valid transition. Yeah.
Just to add to that, so I'm not sure about Starkware's approach here, but for us, and I think like it's a general assumption for every ZK rollup, that if you decentralize, you have to be able to your proof system has to be able to handle invalid batches. So essentially, let's say if you submit a batch that contains invalid signatures, you have to be able to prove that the resulting state is equivalent to the starting state, and therefore there will be some overheads either way. It's just a question of how do you minimize the probability of that happening.
Yes, exactly. And to answer on that, this is why we have introduced Sierra in Cairo 1 to make sure that every thing is probable. I guess you know it, but this is why we have this intermediate representation that makes sure that every Cairo program will be probable, so that we can include reverted transactions. And yeah.
So just as Toghrul mentioned just now, we can introduce some external sequences like the base rollup and other trains to do the sequencing. So Yaoqi, could you give us some explanation about this?
Yeah, so I think the base rollup, well, typically we call it the base rollup, was originally from one of the blog posts I think Justin Drake mentioned in the Ethereum forum. So one of his ideas that so we can probably reuse some of the Ethereum validators, right? Validators to also validate the transactions for rollups. So in that case, as you can see, right, we don't need a separate set of nodes from community or from somewhere, right, to validate the transactions for different rollups. Especially we are talking about in the future, there will be so many rollups. We have a general purpose rollups, but at the same time, we also have a lot of application specific rollups, right? Like the ones that were created, like for games and for NFTs. And so in that case, like it would be great, like we can find a generic place, like the pool of Ethereum validators to verify these transactions. Yeah, of course, it's just one idea, because it also introduced a lot of technical difficulties. For example, in theory, we can ask Ethereum validators to verify the transactional rollups, but it's very difficult to have the logic, I mean, the verification logic of rollup to be bundled or embedded into the Ethereum protocol itself. Typically, we call it in-protocol verification or something. It really requires a hard fork of an Ethereum node, and in that case, they can verify some rollup transaction. But if we really do that way, right, you will see the problem. It's sort of like we want to have L2's rollup to offload the pressure from the Ethereum. But in the end, we still ask the Ethereum validator to do the same thing of the from the work offloading to the L2. So that's why a lot of people discuss about like how we can do that, right? So then we talked to Barnaby. Barnaby is also a researcher from Ethereum Foundation. He's working on the PBS, the proposer builder separation. So Ethereum has a plan to sort of split the task of the validator into multiple roles, right? Builders and the proposers. And right now we already have the Flashbot. I mean, the Flashbot builder is sort of like the PBS builder. So they compose all the blocks and send to the proposers in the Ethereum, right? So once the block is sort of included in the Ethereum network, and also the builders will get some rewards. And then in that case, right, we how to reward these sort of like validators from Ethereum network. They also do the work for the rollups. There are some other solutions, right? One is like the restaking. probably heard a lot recently from EigenLayer or from some other protocols. So you can restake your Ethereum tokens and to some other sequencing network, right? Or just to reward these Ethereum validator if they run actual software to do the verification for the rollups. In that case, they can also get the rewards either from the L2 or from the restaking protocols. So, but so far, right, there are a lot of suggestions, but in general, as I just mentioned, right? So the idea that how can we reuse the existing Ethereum validators? How can we reuse the existing ethers just to help to bootstrap the new rollup or L2 systems? So it's basically try to simplify a lot of work for the rollup projects. If they want probably some new sequencers, or if they want to have some new like sort of stakes, they can just reuse the existing infrastructure or existing stakes. So that's why it's like sort of called based rollup, like it's sort of based on top of Ethereum, and then further the infra and also stakes can be reused for the rollups and L2s. Yeah.
Okay, so Toghrul, do you have any ideas about this topic? Like Scroll have any plans to like integrate the external sequencer systems like shared sequencers?
I'm gonna go on a bit of a rant about it because I'm still not convinced by all the shared sequencer proposals, etc. So, and bear in mind they're still in their infancy. So if the design space changes, then I'm fully for it. But in their current form, I'm unconvinced by them for multiple reasons. So one, for me, the main value proposition of a shared sequencer for like general purpose rollups like Scroll or Starknet is the fact that you can get atomic composability between different rollups. But then the problem is that if you have atomic composability, then the finality of your rollup becomes equivalent to the finality of the slowest rollup that you're composing with. So let's say if Scroll is composing with Optimism, Scroll's finality is going to be 7 days, the same as Optimism. And so like, and the main value proposition of ZK rollups is that the finality, one of the value propositions of ZK rollups is the fact that the finality is relatively fast and you can withdraw to an L1 within minutes. And basically in this case, you're just giving that away. And another disadvantage is that if you want to finalize, if you want to have off-chain finality, meaning that you run an L2 node, and just like as soon as the data commitment on the L1 is finalized, you finalize locally. You can't really do that here without running the full nodes for every single L2 that is composing with one another, which means that you essentially get a system that would probably be more expensive to run than something like Solana, just because you have multiple full nodes running simultaneously and with their own overheads, etc., etc. And yeah, so because of that, I just don't feel like it makes sense for the L2s. For L3s, it's a bit different because I feel like if I'm building an app specific chain, I don't want to deal with decentralization. Like let's say I'm building a game or something, I just want to deal with building the game and I can outsource it. But for L2s, it just doesn't make sense at the moment from my perspective. And with base rollups, I also have my concerns. So for example, how do you share the MEV profits with the provers? Because otherwise, basically the L1 gets to keep all the MEV profits and that's it. And another thing is it also creates a problem where because it's and just one small thing is that it doesn't have the finality or confirmation time is equivalent to L1 confirmation time. So that will be 12 minutes. So you can't have anything faster. And another issue is that because it's permissionless, multiple searchers can submit batches at the same time, which means that at the end of the day, it might have a centralizing effect because if like one searcher is better connected than the rest, the the L1 the proposers, the builders are incentivized to include theirs, and therefore it might have a centralization effect where only one searcher long term remains who is proposing the batches for the L2, which is not a great solution because we're back to basically square one if that happens.
Yeah, it's quite interesting that actually last week I just had a call with the Expresso founder Ben. So we discussed a lot on the shared sequencer part. I think as Toghrul mentioned, right, there are some uncertainties about like sort of the usage for a shared sequencing system, right? It's mainly because like for general purpose L2, typically we won't have a lot of sequencers. I mean, due to like efficiency, complexity, and also economics, right? And I still feel that either for basic rollup or shared sequencer or even risk-taking, right? The best use case is mainly for I mean, like Rust platform or this kind of platform, we can launch a lot of rollups. If we don't really have a lot of rollups, right, we don't really need a big sequencer network, to be honest. Yeah, if we just like a few general purpose L2s, right, they already have their own sequencer system, and all they already engage with their communities or partners, right? They don't really need to have a separate and third-party network. And it's also a burden for the third-party network because you have to be customized for each L2, and each L2, they have different test stack. And basically it requires a lot of changes for your own network. But at the same time, right, if sort of like as Toghrul mentioned, right, for some special use cases, for example, if we want some interoperability at the sequencer level, a shared sequencer can be a potential way to do it. Like for example, the same sequencer is used for multiple rollups, and so it sort of control the sequence of the transactions. So you can predict what are the transaction, I mean the ordering of the transaction for different rollups, right? So in that case, you can basically place in some transaction, I mean cross rollup transactions, to make sure there's atomicity, like rollup A, B, C, they will execute the transaction in order, and there's atomicity. But when I describe this, right, you can also see the problems here. If we really have a lot of such a shared sequencer, right, they are becoming the bottleneck and single point failure. We give too much like power to this like sort of shared sequencer. They are becoming more like a central, I mean, more like a network controlling a lot of rollups, right? So in the end, we will figure out a way how we decentralize this shared sequencer. So, but anyway, I think it's good, like people gradually figure out more and more problems, and also more and more these solutions. Anyway, it's fascinating to see the space is evolving every day, and with all these new approaches and new solutions, right? At least we are on the right track to really decentralize the entire rollup space. Yeah.
Yeah, I agree with both of you. I think it makes more sense for layer 3s and app chains because they don't want to have the burden of spawning a decentralized network, finding incentives to find partners to launch sequencers and whatnot. So yeah, I think for app chains, it makes sense. But yeah, like Toghrul, I'm not convinced for layer 2 for the moment. But I'm very bullish on the app chain part, and I think we will see amazing and exciting design space there. So let's see. But as said before, this is fascinating to see the pace of development in the space, and this is very exciting. Yeah.
Okay, so we basically walked through some primary approaches of decentralizing the sequences. We can have a free discussion on topics like, will these approaches bring more MEV to L2, and how do they work?
Bring more MEV, okay. I mean, for for example, for us, we don't do any kind of MEV in the synchronized context. We just do first come, first serve model. So we don't do any kind of MEV. So it can be only higher than the current status because we don't do any MEV. So for sure, I think it will bring more MEV. But too early to say in which proportion, because it depends also on the design of the consensus mechanism and whatnot. But compared to now, yes.
But the thing is, even if you don't do MEV, there's probably some MEV still happening on Starknet.
Yeah.
And plus, in this case, you choose not to do it, but you can. So decentralization by itself doesn't really reduce MEV or increase MEV. It's orthogonal to MEV, depending, of course. So, for example, if you apply something like Themis or some kind of fair ordering protocol or threshold encryption, then yes, you minimize MEV. You don't completely remove it because I have this philosophy that MEV cannot be removed. You always have some MEV. But let's assume that you're just creating a BFT consensus or something, building on a BFT consensus or something like that. That doesn't really affect MEV at all. Like the MEV is still there. It's just the question of how the searchers work with the sequencers in order to extract that MEV.
So the thing is like for even for first come first serve, right? There's a tricky part that once we make the mempool, right, mempool public, so for some searchers, right, they still have the advantage to leverage. For example, for the sequencer, right, they probably have the best network. Yeah, sort of they have an office just net to your door, and to have the best network to connect to the sort of the sequencer. So in that case, once they see some sort of arbitrage opportunities, right? MEV not just about front running or sandwich attack. It's like a user send transaction, right? And they can immediately see in the mempool. So since they next to your door, right? So they can quickly place their transaction ahead of the other guys. So they have the advantages over the other sort of searchers. But back to the decentralization, I think it's relatively I think it's mainly to prevent the censorship, like we just discussed at the beginning, right? If it's just a single sequencer, right? It's run by the team. The team can say that they are quite fair to everyone, but you cannot prevent. I mean, in code, right? So it would be great, like we can have a P2P network if we feel that this node block my transactions, and then we can send to other nodes, right? So it's really about the fairness for precising transactions on the L2 side. Regarding MEV, I mean, because recently, apart from the single rollup MEV, right, there are also some MEV across bridges. For example, there are bridge across two rollups, right? And in that case, it's sort of like you have more opportunities to leverage when you have a relatively decentralized sequencing network, especially assume we have the shared sequencer network, right? So if you can somehow have the influence on the shared sequencer about the reordering of the transactions, basically you have a much bigger advantage over the other guys. For example, if you are running a shared sequencer across different rollups, right? Basically, you can reorder your transaction ahead of the other guys, not just for a single rollup. It's basically across multiple rollups, and I would say that's a pro and cons. Pro side, we want the decentralization for the sequencer system, but con-wise, everyone has the opportunity to become a sequencer. So they can basically do anything they want, right? It's a dark forest again. So basically we introduce decentralization, and then we have to face sort of the similar problems we were facing at Ethereum. And then that's why Flashbot people, Ethereum people, they want to have the PBS, right? They want to like separate the proposer and the builder, and then try to have a separate solution on the builder side. We can use a swap like basically use SGX, right, to prevent some of the MEV, or to make it like a fair auction, right, for the MEV to basically make the MEV distribution in a fair manner. So that's why when we look at the problem, right, it's not just a single problem. Basically, once we want to find a solution to this problem, at the same time, we have to figure out the solution to all the other subsequent, probably 5 or 6 problems. So yeah, that's the most tricky part. There's so many caveats. It's no longer it's like a 1-to-1 problem or question. It's really like 1 to 6 or even more. This kind of question and answers. Yeah.
Okay, so I think that's the last question. So, and we are done here for this panel. So thank you again for coming to ECM podcast. And I hope your project is going well in the future and come out more cool stuff. So thank you, Yaoqi, Abdel, and Toghrul. So see you all next time. Bye-bye.
Yeah,
Thank you.
Bye-bye.
Bye.